There we go. A little bit more sunlight. Welcome back, scholars, to our final installment for your pre-calculus journey, where we're going to talk a lot about trigonometry. So we're going to start off very slow. It's going to be probably pretty uncomfortable because we're going to talk about these types of functions that have something that's known as periodic behavior. Um, you might be able to use your intuition to kind of feel out what that word is actually representing. But we're going to comprehend that periodic functions are ones with outputs that repeat at regular intervals. So I can use the Pythagorean theorem to find coordinates of points on a circle centered at the origin. I'll know I've got it when I understand that a periodic function is one with outputs that repeat at regular intervals. I'd like for you to select the clock that you feel does not belong and state the reason for why that particular clock does not belong. A clock is a great example of a periodic function because it replicates its behavior over a particular interval. So our first situation is we have a ladybug that lands on the end of a clock second hand when the hand is pointing straight up. I've given you the opportunity to draw a sketch so you could assist yourself with the visuals. The second hand is 1 foot long, so I know that this is going to be 1 foot long. And when it rotates, it points directly to the right. The ladybug is 10 feet above the ground. Right, so it's 1 feet, but as it rotates, when it's pointing directly to the right, so that would be at 3 o'clock, this distance to the ground is 10 feet. How far above the ground is the ladybug after 0 seconds have passed? Well, since I know that the length of the second hand is 1 foot, and that when the ladybug or the hand is at 3, we are 10 feet above the ground. With 0 seconds have passed, that would be a total of 10 plus 1 for 11, right? Because this point here, right, the center of the circle, or the center of the clock, would be considered 10 feet as well above the ground. 30 seconds have passed, right? That would mean that my second hand is pointing down at 6. So I've clearly gone closer to the ground. And I'm going to leave these final two values for you to work out. In addition to these 3 values that we might need to estimate. So I'm interested to see how you're able to come up with your particular values. So how far above the ground is a ladybug after 10, 20, and 40 seconds have passed? If the ladybug stays in the second hand for a full rotation, describe how its distance from the ground will change over the next minute. What about the minute after that? What do you notice? There should be some type of repetitive or periodic behavior that is unfolding. At exactly 3:15, the ladybug flies from the second hand to the minute hand, which is 9 inches long. How far off the ground is the ladybug now? All right. So a clock emulates a circle. Trigonometry is ground in a circle. So we need to go back to our geometric ways and consider the properties of a circle, theorems associated with circles, and any other prerequisite knowledge. So for this one, I'd like for you to have some dialogue with your peers and to describe how could you, if we had, placed a coordinate plane here, how could we find the location of point P marked on the clock? What could we possibly do? And think about possibly maybe using this to reference or assist you in your response. As we can see here, The horizontal distance for this coordinate is -5. I unfortunately cannot draw. And the vertical distance is 12. If you were to physically, actually, I might be able to. Can I? Let's see. Okay, there we go. 12, 5, and we want to know the value of the radius. Based on the image that I just drew, a theorem should erupt from your mind about how we could possibly calculate the radius, and then obviously detail that exact thought process. Right, so if I know those two lengths are -5 and 12, then how could I use that piece of information to determine the radius? Now, that information should prove useful because in both of these situations, we're told that we're told a particular coordinate, in this case, the y-coordinate, having a particular value. We're told the radius, and now we're tasked with determining what the x-coordinate is. Very similar to what we're doing here. And by this point, if you're still stuck, I'll give you that as a starting hint, but a slight adjustment in our approach for these two particular questions, with this being a huge hint as to the type of theorem that you need to assist you here. And then, as always, we'll pick it up together in class.